The first question says, add this, okay? Repeat the procedure to obtain a consistent titer. That's the titer value that we've obtained so far. So what's next? The question says, from your result, calculate the concentration of B. The concentration of MnO4 in B in mole per dm cube. All I need to do is to write out the parameters. Write out the parameters. As you can see from here, I was given A is the solution of this. The 0.05 mole per dm cube here is the concentration of A in mole per dm cube. So concentration of A in mole per dm cube is 0.05 mole per dm cube. So we call this our Ca, which is our Ca. So our Ca equal to 0.05 mole per dm cube. So we've gotten our Ca to be 0.05 mole per dm cube. Put this exercise into this, okay, pipette 25 cm cube of A. So the volume of A, of solution A, which is our Va equal to 25 cm cube, 0.00 cm cube. Now the volume of B, volume of solution B, that is the Vb, is equal to the average titer value obtained, because KMnO4 was our B. So this one is 18.40 cm cube. So we are looking for the concentration of B. So concentration of B, that is as in mole per dm cube, that is Cb equal to question mark. So for the fact that we've gotten our Ca, we've gotten our Va, we've gotten our Vb, we are looking for our Cb. There is a formula called Cavanagh. That is CAVA equal to CBVB. So using Cavanagh, equal to Na over Nb, where Na equal to the mole ratio of the acid. This is the acid, oxalic acid, and the mole ratio here is 5. Equal to 5. Our Nb equal to 2. So we'll fix everything into this. We've known all this. So from this, our Ca becomes 0.05 multiplied by Va. Va from the question is 25 over the Cb, which is what we are to determine, multiplied by Vb, which is 18.4, equal to Na is 5 over 2. Making Cb the subject of the formula. Making Cb the subject of the formula. Cb multiplied by 18.40 multiplied by 5 equal to 0.05 multiply by 25, multiply by 2. So our CB, which is the concentration of B, becomes 0.05 multiply by 25 multiply by 2 over 18.40 multiply by 5. So when you do that, at the end of the day, it becomes 0.05 multiplied by multiplied by 25 multiplied by 2 equal to 2.5 over times 5 equal to this 9.92. So our CB at this point becomes 2.5 divided by 92. 2.5 divided by 92, which is 0.0271 mole per dm cube. Now the standard is concentration in mole per dm cube must be in 3 significant figures. So the final answer becomes CB becomes 0.0272 mole per dm cube, which is the concentration of B in mole per dm cube. The final question says, if in order to prepare B, 2.50 gram of impure solid was dissolved in 250 cm3 flask and made up to the mark, calculate the percentage purity of KMnO4. How do I do this? All I need to do is, a standard solution is we are to prepare equal amount of an unknown solution of the sample in 1000 cm3. That is, for question B, this is question A, the final answer to A. B says, okay, this is question C. This was A, the titer value was A. This is B, so this is C. C says if in order to prepare B, 2.50 gram of impure solid was dissolved in 250. How do I go about this? If 2.50 gram of the solid dissolved in 250 cm3, it implies that X gram of the solid will X gram of the solid will dissolve in 1000 cm3, making X the subject of the formula. X becomes 2.50 multiplied by 1000 over 250. So X now becomes 0.0271 2.50 multiplied by 1000 equal to this, divided by 250, which is 10 gram per dm cube. This is the mass concentration. The unit gram per dm cube is the mass concentration of the impure salt, the impure solid of the impure solid. All right. So for we to get the percentage purity, we need to know the concentration of the pure solid. How do I do that? I've known the concentration of the impure. How do I know the concentration of the pure, the mass concentration of the pure solid? Concentration in mole per dm cube equal to mass concentration in grams per dm cube over molar mass. Over molar mass. And I need to get the molar mass of the KMnO4. The masses of the individual elements in the KMnO4 is given to us. So I need to get the molar mass of KMnO4. Molar mass of KMnO4 equal to K is 39.1 plus Mn is 54.9 plus oxygen is 16 multiplied by 4, which is equal to 54.9 plus 39.1 equal to 158. 158 gram per mole. The unit of molar mass is gram per mole. So I've known the molar mass of KMnO4. I've known the concentration in mole per dm cube of solution B. All I need to do now is to get the mass concentration of solution B. To do that, I need to fix in the values into this formula. It becomes concentration of B is 0.05. Concentration of B is 0.0271. 0.02717, which was the raw value. So I'm using the raw value instead of the approximate value. So from this place, it becomes 0.02717 equal to the mass concentration of B, mass concentration of B over the molar mass of B of solution B, which is over 158. So when you cross multiply, When you cross multiply, the mass concentration of B becomes 0.02717 multiplied by 158, which is 158 multiplied by 0.02717, 0.02717, okay, equal to 4.293 gram per dm cube. So this is the mass concentration of the pure KMnO4, of pure KMnO4. And I'm to determine the percentage purity of KMnO4. So percentage purity equal to mass concentration of pure over mass concentration of impure times 100 over 1 is equal to the mass concentration of the pure is 4.293 over the impure was 10 gram. This is the impure, the mass concentration of the impure, which is 10 gram multiplied by 100 over 1 times 100 divided by 10. So percentage purity of KMnO4 equal to 42.92%. This is the percentage purity of the KMnO4, which is 42.92%. And as you can see, it's a very simple calculation. All you need to do is keep to the steps, study harder, and it will help you when you come across questions like this. Thank you once again for staying with us. And don't forget that these apparatus are very important when it comes to volumetric analysis. Now, who can tell me the use of the Bunsen burner? All right, you're right. The Bunsen burner is used for heating. As you can see, we heated the reagent for 40 degrees Celsius before conducting the experiment. Thank you and God bless you.